Okay, I would like to show you that Kirchhoff's voltage law does not work if the source of electrical potential in the loop is provided by electrochemical cells. Now, if you're Professor Walter Lewin, you need to take this seriously. For everyone else, this is a joke. And here's the background. Professor Lewin drew this diagram and said he had these 2 voltmeters connected to exactly the same points, these 2 points here and here, and he showed that they measured different voltage. In reality, his probe wires actually ran parallel along the same path to the windings in what was essentially a transformer, and so while he had his probes connected to the same 2 points, he had voltage induced in them along here, and so the voltage that was induced in this line was then subtracted in this line, just like having 2 batteries, plus to plus or minus to minus. So his actual voltage reading was as if he had connected directly to the resistors like this. So this is how he should have modeled his circuit, or he should have modeled it indicating that these were coupled transformer windings. But he insists that his 2 voltmeters were connected to exactly the same 2 points and that they gave different readings, and he insists that the 2 voltmeters were absolutely identical. So what I've done here is I've got 2 voltmeters that are in fact identical, very close to it. They're less than 100 counts apart on serial number. I bought them on the same day from Amazon. And you can see I have a loop here. It's got a couple of about 1.5 volt batteries. They're not exactly 1.5 volt batteries because they're old and they're under some load, and so they're drooping a bit now. These are pretty close to 1.5 volt each because they're under no particular load. But anyway, I've got about 3 volts produced here, a voltage dropping resistor, another 3 volts here, another voltage dropping resistor here. So this is the loop. Now, as you can see, Professor Lewin, these 2 voltmeters are identical and they are connected in the exact same 2 locations. See? The electrons have to flow right through here, right there. There's no way for electricity to get from this inner loop to either of these voltmeters except flowing through this single wire and this single wire. So these 2 voltmeters are in fact connected to exactly the same 2 points, there and there. Okay, but look, these 2 identical voltmeters give drastically different voltages. This one gives like 4.5 volts, and this one gives negative 1.4 volts. So what's going on here? Well, it's quite clear from this that Kirchhoff's voltage law does not hold if the source of voltage in the loop is produced by electrochemical means. Now, I haven't tried solar cell means, I haven't tried Peltier type means, but at least we know that electrochemical doesn't work, and Professor Lewin has shown that inductive sources don't work either. And I think by trying a number of different things here, I could demonstrate that Kirchhoff's voltage law never ever holds for any scenario, because these 2 voltmeters are clearly connected at exactly the same 2 points, and yet they read drastically different volts. And you can see I've laid out my circuit here. I'm using little magnets. It all sticks together. I have little magnets, little metal strips, little resistors. See, here's my little loop, just like this loop here. And here's these. Just don't worry about these. These are just those, yeah. Okay. So, if you're a physics professor and you think Kirchhoff's voltage law doesn't hold with inductive voltage sources, now you know it doesn't hold for electrochemical voltage sources either. So, the world is getting better and better all the time. Now, for everybody else, you probably should understand this. Most of you have already figured it out, and you're saying, that guy's stupid, he's making a silly video, and yeah, you're right. But what's happening here is I've inserted these batteries in line with my voltmeter leads. Now, I'm not considering them when I do my analysis of this loop. I'm not considering them because, see, I'm telling you that these 2 voltmeters are connected to exactly the same 2 points. And I'm telling you that these 2 voltmeters are identical. Only one of those 2 things can be true. If these 2 voltmeters are identical, then these batteries must be modeled as part of the loop, as part of our circuit under test. Then, if I am willing to admit that these batteries, these top and bottom pair of batteries, are part of the circuit under test, then these voltmeters can be considered identical, but then the 2 voltmeters are not connected to the exact same place anymore. They're connected on opposite sides of these batteries. And if you do the math, you'll see that if you add these 2 voltages, it is in fact very close to 6 volts from the sum of those batteries. Now, on the other hand, we could say, oh, these are not part of the circuit under test. Only this is the circuit under test, and these voltmeters are in fact connected, and we can group these batteries as part of the voltmeter, but then we've got to admit that this voltmeter has a negative 3 volt error offset, and this voltmeter has a positive 3 volt error offset. And when the 2 voltmeters have different error offsets, they are no longer identical voltmeters if we're considering this whole path as part of this voltmeter and this whole path as part of this voltmeter. So we can say they're identical, but they're not connected in the exact same place. Or we can say they're connected in the same place and model these batteries as part of the voltmeters, but then we must realize that these voltmeters are not identical. They have different error offsets added to their measurement. And in my humble and totally unbiased opinion, that is exactly what Professor Walter Lewin's apparent paradox is about, because he tells us that his 2 voltmeters are connected in exactly the same place and are identical, when in fact there is voltage induced in the leads, and he models it neither as a differential error on the voltmeters, making them different, nor does he model it as part of the circuit under test. And so that's why we get this apparent paradox of 2 voltmeters that read the different things when they're connected to the same point. You can group this as part of the voltmeter and admit that they are not identical, they have different offsets added to them, or you can group them as part of the circuit under test. And then the 2 voltmeters you can consider identical, but you got to admit they're not both connected to the same point, because in fact they're connected here and here, which is at the other end of this secondary winding in this transformer. So that's about it. Let me pop this phone out of here and give you a closer up view. Okay, so there's our battery setup. Just got little magnets sticking it all together. Little brass strips, or zinc strips. Some resistors. These voltmeters are actually pretty nice. They're like about 20 something bucks on Amazon. And they seem really nice. They do quite a range of features: capacitance, frequency, current, voltage, resistance, transistor check. There's they call them 6,000 count voltmeters, but they're really only accurate to within, probably a percent or 2 or something. But anyway, they still allow you to measure 2 voltages and say tell what the minute difference between them is, even if their full scale voltage is off a bit. But they're pretty close, especially for a cheap voltmeter, but they work great. And of course there's, oh, that's not it. This is it. That's my diagram for those of you on low quality internet that can't show HD video. All right.